Help video, simplify algebraic square roots. Alright, so with square roots, you guys, first we should probably make a prime factorization tree of the number on the inside the square root. So, we'll break this down. Offhand, 2 times 54. 54 breaks down to 6 times 9. The 6 breaks down to 3 and 2, and the 9 breaks down to 3 and 3. Now, it's always with square roots, it's a root of 2, you guys, so you try to find your groups of 2. And there's a reason why we find our groups of 2. So we found a pair of 2s and a pair of 3s. So, and we have a leftover of a random 3 right there. So what we're going to do is we are going to write 5, because that's already on the outside. Now, write down your the pairs and the numbers. So we found a pair of 2s, so a 2, and a pair of 3s, we're going to write just a 3. And since there was a leftover, we're going to have a square root so far of that leftover of 3. Now if you're wondering, okay, why does the 2, how do we get a 2 from 2 2s? And how do we get a 3 from 2 3s? This is the reason why. When you guys have square roots, you're trying to find perfect squares, because we can take the square root of perfect squares. So what really is 2 times 2? Well, 2 times 2 is 4. And because this is all under the square root, what is the square root of 4? The square root of 4 is 2. And when we do 3 times 3, you guys, what's 3 times 3? It's 9. And that would still be under the square root, and what's the square root of 9? 3. So when we find these pairs, you guys, we're really trying to find the perfect squares within 108 so that we can simplify it and bring those on the outside. So our pairs are groups of 2, they go on the outside, and our leftover of 3 goes on the inside, because we can't simplify the square root of 3. Now let's look at our variables. Take the exponents and divide it by the root, and the root is 2. So 5 divided by 2, 2 times 2 is 4, left over 1. So there'll be 1x on the inside because there is 1x remaining. And we'll have x to the second power on the outside. And the reason why for that, you guys, is because x to the fifth, that can become the square root of x to the fifth, you guys, can become the square root of x to the fourth and the square root of x. We know what the square root of x to the fourth is. What times itself is x to the fourth? That would be x to the second, which is why that's on the outside, and on the inside we have the square root of x. Just to give you guys some background. Now let's look at the variable of y. Take the exponent and divide it by the root. Square roots, you guys, are roots of 2. 2 goes into 7 3 times with a remainder of 1. So there'll be 1y on the inside the square root, and we'll have y to the third on the outside, because that y to the third is one of the perfect squares that we can get from there. Simplify all that, we get 30x squared, y to the third, square root 3xy. So there's that one. Number 2, same thing. Let's break this down. 5 times 35, 5 times 7, pairs of 5s, and a leftover of a 7. So I'm going to run out of room, so I'm going to actually bring this over down here. Okay, so x to the third, we found a pairs of 5, so 5 is going to pop out. Same thing as taking the square root of 25. And we have a leftover, so the square root of 7 will go on the inside the square root. Now let's take our exponents and divide it by the root, which is 2. So that one was for the x variable, so we'll have 1x on the inside the square root, and an x to the third on the outside. For y to the fifth, we'll have, we'll have 5 divided by 2. So 2 goes into 5 twice, with a leftover 1. So we'll have a y on the inside and a y to the second. And again, the reason for that, you guys, is because the square root of x to the 7th, you guys, can split into square root of x to the 6th and the square root of x. Square root of x to the 6th, you guys, is what times itself gives you x to the 5th, which is x to the 3rd. Which is why we got that, and an x on the inside, you guys. And for square root of y to the 5th, you guys, that breaks up to y to the 4th and the square root of y. And this is a perfect square, you guys, because square root of y to the 4th, 1 times itself is y to the 4th, that's y to the 2nd. So just showing you guys some background on why this method works when simplifying our square roots. Now let's just simplify this. 5 x to the 3rd times x to the 3rd, you guys, is x to the 6th. You add the exponents. Y to the 2nd, square root 7xy.